This video is about how I built a production SaaS application in 1 month using Claude CLI. The solution is for automobile manufacturing industry. The solution already exists for tier 1 suppliers, but for tier 2 and tier 3 the solutions are not practical in terms of budget and teams and the scope. So this is the solution for tier 2 and tier 3. To understand this solution, first we need to understand what problem it's solving. The problem is PPAP, production part approval process. PPAP in automobile manufacturing is, suppose Tata, Mahindra, and Yamaha. All these OEMs don't go on awarding the parts manufacturing contract to suppliers. They send their engineering drawing and requirements, and supplier need to send a document package proof of quality and the quantity. Suppose we have all the machines and the industrial standards and everything in place, which will guarantee that you will get the desired quality and the quantity. And this package has 18 types of documents like process flow diagram, control plan, and master sample, or records of compliance, dimension results. So these 18 types of documents are sent to the OEMs, and then they evaluate the documents and decide whether to give the contract or not. So AuditReady comes here. AuditReady is a SaaS platform which manages this full PAP life cycle from draft to submitted, from approval to reject, whatever approval rejects happens on the OEM side. And it tracks the 18 element per project. And there is OEM review portal where once the documents are submitted, then OEMs can review it. And one more critical compliance part is it is IATF compliance audit trail is there. So every operation, who did what, when, from what IP, all of this is recorded and the records are immutable. And one star feature of the application is a AI document review, which is powered by RAG. It has all the company standards and all quality standards, company standards, past submissions. So the whole knowledge base checks your documents and cross checks with the standards and points out mistakes before the OEM does, saves time, and judges against the OEM profile and OEM standards. And it gives you a confidence score, so that okay, should I, so suppliers can be confident about the submissions, or they can be like, okay, I can improve in these aspects. So AI provides that as well. So let me give you a quick demo. First, we'll log in. So, as I'm a supplier, I have customers. There's Tata Motors or Yamaha. I can configure customers here. Once I configure customer, for those customers, I'm building parts, rear axle shaft. For Tata Motors, I'm building. So in my PAP submission, rear axle shaft, we open. Here are 18 elements. Each element is version controlled. Any supplier can have his own team. So each element is assigned to. So as a owner, I can assign this to any person in my company. So there can be multiple accounts, a owner account and a team account. So here there is assignment feature. Every document is version controlled. There are other details like quality data. Once the whole PAP is done, there is part submission warrant details which are auto filled. If there are some trial runs, those trial runs also recorded here, and whole timeline is tracked, so the client will know what date what happened, and these are all immutable. And here all the activities records are kept, so it helps for audit trail. There is this star feature, that is AI review. This AI review will evaluate the PAP submission, and it will show you that there is a risk, this is the place where you can improve, what is the acceptance score. And we also have reports where in past how much was the approval rate, at what stages this PAPs were rejected, and what parts are at risk. So all the analytical view will be here in reports. This is a AI powered document review. I just showed reports and analytics is there. So in production, there are 3 services, 2 domains, and 18 elements per prior project, and 10 plus feature shift. Just to list down few features, we have full PAPS lifecycle, public OEM review portal, part submission warrant structure, and OEM specific CSR fields, AI powered document review is there, in app and email notification, multi user management and invites, role based access is there, and full IATF compliance audit trail will be there. So let's look at the architecture. Currently in backend, I have Nest.js. In front end, there is React, mostly hosted on Google Cloud. In front end, there is Redux for state management. I have React Query, hooks, and Tailwind CSS. In backend, using type ORM with PostgreSQL. There is asymmetric JWT keys for authentication, Recent for email, Bruno for API testing, Docker as our backend services are containerized. The whole infrastructure is deployed on GCP. The database is on Superbase, and I'm using GCP Cloud Storage, Cloud Run, Artifactory for hosting the containers. In front end, there's Vercel and Cloudflare for DNS, and this is the system architecture diagram. There are two services. The reason why I made two services is I have a skeleton service which I can reuse across multiple SaaS platforms in future. This skeleton service has everything which is not related to business logic like payments, subscription, multi-tenancy, and the database data layer, we have PostgreSQL for secrets, we have asymmetric JWT keys for email, we are using Resend. This supports a multi-tenancy architecture. Each table has company ID. All queries filtered by company ID. No cross-tenant leaks. Service layer enforcement is there. Service method validate ownership and not just controllers. There is role-based access. There is session management, and there is also OEM review without logging in, and this follows a different authentication mechanism altogether. For the main login and for the user, we have JWT across two microservices. As this is asymmetric, so it is more secure. Only auth service holds the private key and signs it, and PAP service holds the public key and verifies it. PAP service breach cannot forge tokens. So file versioning per element is there, version controlled, and is current flag is obviously which tells the is current flag, it tells the system that okay, that is the current submission version that we need to submit. Cloud Storage is used. So okay, how I built it? Well, I built this using Claude CLI, and designing is very important when it comes to Claude CLI. Your specs are the truth, and more accurate your specs are, you're going to get a good result from Claude CLI. So first I did is first get the exact requirement right, user intention right, business flow, use cases, deep research on the market, user flow, business process, edge cases. So all this goes into a requirement.md file. And then comes data. Software is manipulation and storage of data. Get the data model first right. Everything else follows. So using Claude Opus, I designed first ER diagram. Claude Opus is very good at figuring out the ER diagrams, entities, and their properties. And by looking at the edge cases and user flows, it can figure out what kind of properties we will need. So all this will go into ER diagrams. Once we have ER diagram nailed down, then I created a architecture.md file. And here actually knew already what I wanted, so that this was easy part. I wanted two skeletons, one skeleton service and one business service, and API contracts. From after architecture, we have API contracts. Claude and AI is very good at filling the blanks. If you give it a starting node and an end node, then it is very good at figuring out what lies in between. When we have business cases clear, entity relationship clear, and the API contracts clear, then when we give it the whole thing to Claude, then it can figure out the front end things very easily without hallucination, as there is no uncertainty, there is no room for uncertainty, and the clarity comes from the documents. So yes, like I mentioned earlier, the reusable skeleton service takes care of multi-tenancy, company scoping, and tenant isolation. It takes care of authentication, user management, session management, email infrastructure, audit logging, etc., etc. Everything which is not related to business. So I can reuse this in my future SaaS platforms. And business service. In business service, everything related to business is here. And working with Claude CLI, my go-to method is first, I once I have the whole design ready, I make a plan. I plan the whole thing with Opus. Once I have that what I need to do, exact list of things I need to do, then I divide it into sizable chunks. Claude works very well in boundaries. So don't give Claude the whole project, it will hallucinate. Give it one bounded task with enough and only enough context. We have almost 1 million context, but it's good to make sure that we only use 50% of it to have very good accuracy. So divide in phases such a way that it can consider a phase in a whole context. So divide into phases, and then a phase should be divided into multiple tasks. Each task and Claude CLI will use executor to execute each task. For executing task, I mostly use Sonnet 4.5. Now recently the 5 came, and I monitor and steer the development. While developing the whole thing, I have created a lot of slash commands which make my life easier as a developer. I can create, do a feature analysis, create a feature requirement, create a feature plan, then execute that plan, and then leave some notes for that next Claude session. It can have a good context. And for operations and productions, I have slash commands which will a Python script which will deploy the whole infrastructure and application to production. I have slash commands to monitor health logs. If I want to check something in DB, I can do that, and I can seed the any account I want for demos. I maintain a index.md for all the important files and their small metadata about those files so that Claude can have a compressed view of the whole code base. And I also have a slash command for doing regression and running test cases. When it comes to Claude CLI, your structured context is token efficiency. You need to be sparse about how you are using your tokens. The context should be clean, very minimal, and whatever is required should only be considered in your context window. I have the Claude.md and I have modes here, task mode and testing mode. Whenever we are in task mode, it is about feature development, planning, and deployment checklist. But when we are in testing mode, the Playwright MCP details and Bruno test MCP details, Python test MCP details, all those things are there. So once I'm developing a feature, I switch between these two modes to make sure that I'm getting the feature right. Claude.md is pointing towards the index.md, showing all the one liners per file. And I have Playwright MCP rules so that front end is created by considering testability by Playwright MCP so that it would be simple enough, but so that Playwright MCP can test it efficiently. When it comes to Claude CLI, feedback loops are very important. The more stronger your feedback loops are, the more efficiently it knows how its output. So Playwright MCP gives it ability to see its front end output so that it can check its own output and reiterate and better its own work. And for the backend, there is Bruno and also Python scripts, which also helps the Claude CLI to know if whatever he is doing it's right. You must have a strong feedback loops. When it comes to infra, I have one deployment command, one deployment script. I trigger with my slash command. After the deployment, it can do the monitoring as well. For good observability, I have Grafana dashboards, structure JSON, production CLI commands like health check, log errors, and log trace. I can also check DBs directly to see what users are doing. Lesson learned. Start with data model. Data is the most important thing. If you get it wrong, your application going to suck. That is the truth. So data is very important. Start designing with the data model, entity relationship diagram, review it, and then write entity case classes. From day one, use Terraform. Claude CLI is very good at managing infrastructure. Third party services like Google, Cloudflare, Superbase provide their own API key. You can use that API key and configure it into the project and install their CLI tools. Cloud CLI can pick it up from there. It can use Terraform as well as the CLI tools to manage your infrastructure. AI quality is your design quality. Your specs should be very clear about what you want, and what you don't want should be even more clear. Giving AI boundaries to work within is a great idea, as it hallucinates less, and as there is much uncertainty when you give it boundaries, it will perform very well. So yeah, that's pretty much it. If you have any queries, to drop a comment, let me know.